idea when that went off. I don't know when the camera went off. If it went off before I solved the whole problem, you got it right there. All right, so the last thing we're going to do is part C of problem 6 on the review sheet, just so I can say I really reviewed everything. So we've got y double prime minus 8y prime plus 17y equals e to the 4x times the cosecant of x. Okay. Once again, what is step 1? Auxiliary equation, which is r squared minus 8r plus 17 equals 0. Perfect. Okay. And how am I going to get the roots? Quadratic equation. Very good. So r is equal to, okay, simple stuff here. A lot of people on the quiz, there was a minus here. They still put minus there. Remember, it's negative of b. So if that's already negative, it becomes positive. So positive 8 plus or minus the square root of 8 squared, which is 64, minus 4ac, which is 17 times 4 is 68, all over 2. So 8 over 2 is 4, and radical 64 minus 68 is negative 4, and we take the square root of that, we get 2i, and then we divide by 2, so we get 4 plus or minus I. Anybody have a problem with that? So we can write down the complementary function, y sub c. What would the complementary function be, Robert?
C1 e to the negative x. Pardon. C1 e to the 4 plus I.
Well, you've got the 4 is the real part.
Right.
Okay, so this is c1 e to the 4x. We just leave it like that.
And then cosine x plus c2 e to the 4x sine x.
Great. Okay? Very good. Complementary function c1 e to the 4x times cosine of x plus c2 e to the 4x times sine of x. Love it. Okay. All right, what's the next step? The particular solution, y sub p. And to get that, what do you propose? We don't know how to annihilate this. Of course, you'll have a table of annihilators. It'll be the same one I gave you Wednesday on the quiz. And it's not going to have cosecant of x in it anywhere, right? So what you're going to need to do is solve it by the other method that we learned, which is variation of parameters. This is second order, so that is feasible. And so for variation of parameters, we just need to remember the formulas, really, for how it works. So the way that the variation of parameters formula works is you take the solutions that you already wrote down, and you call them y1 and y2. So y1 and y2. And then the particular solution, this is step 2, the particular solution is going to be chosen to have the form u1 y1 plus u2 y2. Okay, and our job is going to be to find u1 and u2, but that just involves knowing the formulas. So remember the formulas here. u1 is negative the integral of y2 big F over the Wronskian. And u2 is positive integral of y1 f over the Wronskian. So just need to know those formulas in a very abbreviated form there. I think it's pretty easy to remember. There's a minus sign on the first one, though. And it actually doesn't matter which of these two you labeled as y1 and y2. At the end of the day, your solution is going to be acceptable. You'll get the right answer either way. So it doesn't matter. Okay, so let's just try this out. Okay, let's try and figure out u1. So u1 is what? It's negative the integral of y2, well, that was e to the 4x sine of x. And that's y2. Oh, maybe we should just do the Wronskian first. Yeah, okay. I'll come over here. Let me do the Wronskian. The Wronskian W, that's the determinant of. Okay, so we'll do this first. Just get it out of the way. So the first row is what?
E to the 4x cosine x.
E to the 4x cosine x. And what else?
E to the 4x sine x.
Good. E to the 4x sine of x. Now's where it gets fun. Yeah, we have to take the derivative of this. Okay. So I have to use the product rule on it. Okay. So the derivative of e to the 4x cosine x is negative e to the 4x sine of x. Okay. Plus 4e to the 4x cosine of x. Didn't give myself much room here. And then on this entry, put down here, we take the derivative of the upper right corner and we're going to get e to the 4x cosine of x plus 4e to the 4x sine x. Okay? And we have to take the determinant of that. So this is, at least it's only a 2 by 2. So this times this minus this times this. Let's see. There's a lot of cancellation that goes on. Yeah.
Can we like on the test not go through it if we see it, or do you want us to?
Try and show
Because
some
we
work.
always know that's like gonna be e to some power, right?
I don't know if we
Most of
always
them.
know that.
Okay.
Let's be a little careful. Yeah, you never know. Never say never and never say always. So, what were you trying to say, Greg?
Usually is like e to the like 8, like there'll be like 2 times whatever the coefficient of x is.
It does feel that way, doesn't it? That's the way the homework has been going.
Yeah.
Well, you see it here. Here's e to the 4x times e to the 4x, right? So let's just write it out, okay? This is the last thing we're going to do. I think I got the energy for it. So e to the 4x cosine of x times e to the 4x cosine of x plus 4e to the 4x sine of x, right? And then minus e to the 4x sine of x, just doing this determinant right now, times negative e to the 4x sine of x plus 4e to the 4x cosine of x. Okay. So something must cancel. I think that these terms cancel. Because you've got positive 4 times sine x cosine x, right? You've got both of them with a 4 here and 2 exponentials. Down here, same thing. Sine and cosine with a 4 here for 2 exponentials. But this one's subtracted. There's this minus sign right here in the middle of everything. So those 2 things cross off. Okay? And then what we're left with is e to the 4x, that's e to the 8x. E to the 8x times cosine squared of x. And then minus a negative, which makes it positive, e to the 8x sine squared of x. And when you add that all together, you get e to the 8x. Okay? So there you go. E to the 8x, that's our Wronskian. Everybody good with that? Oh, come back over here. We'll put the Wronskian on the bottom. Okay. W's on the bottom. We've got negative y2, which was e to the 4x sine x, and then capital F, which is actually e to the 4x over sine of x. And now that has turned out just to be lovely, because everything cancels completely. And we just have minus the integral of 1, which is negative x. Oh, dx, thank you. Leaving that off. But there's no plus c. no plus C. Yeah, I mean, technically I should have that here too. I just try to keep the notation simple, but yeah. Okay, great. And then we have the other one, which is U2. This is going to be the integral without a minus sign of y1. That would be e to the 4x cosine of x times capital F, which is e to the 4x over sine of x. And the cosecant is 1 over sine. And then the Wronskian, which was e to the 8x. So this time, it's not quite as trivial. We get the integral of cotangent of x. And yeah, that's going to be on the table. I'm pretty sure it's there. Yeah, it's in the table. So it's just the natural log of the absolute value of the sine of x, like that. Okay? So you can look that up in the table. So then your particular solution, your final answer for your particular solution is, as we said, u1, y1 plus u2, y2. And we've got u1 and u2 now. So it's negative x times e to the 4x cosine of x. And then plus the natural log of the absolute value of the sine of x times y2, which is e to the 4x sine of x. There you go. It's all good? And then the general solution. The general solution is all of this plus all of this. Right? Should I write it down?
Yeah.
That was pretty decisive. Yeah, but you guys should at least write something down. Don't just stop here. You should write down at least y of x equals y sub c plus y sub b, where you have clearly indicated what those two parts are above. So that's about half the parts. That's probably enough. We've been at it for quite a while here. So there's a couple other things on the sheet we didn't actually do. We did most of it though, and we've definitely talked about all the relevant material. Just figure out where your weaknesses are. Most people did variation of parameters very well on the quiz. The bigger issues were with finding the lambdas for a 3x3 matrix, getting your eigenvalues, eigenvectors. That's you're gonna have to do that. That's gonna be a big part of the chapter 5 stuff is finding eigenvalues and eigenvectors. Question, Greg?
Yeah, tomorrow, what time is the review session tomorrow? I'm just
Tomorrow, on Sunday, the review is,
Don't get stuck in
just take the
elevator.
stairs this time. Starts at 1 o'clock for those people who take the stairs.
Are you gonna record it too?
I don't know if I'll record it again, because I think I got a pretty good recording today. So from 1 to 3, and then I have office hours this evening, although I'm going to take a little break here for a little bit. And then I'll be around tomorrow evening as well. So feel free to come on by if you have questions.
Are we doing the same problems?
I'm basically going to do the same problems. I mean, if I'm a little faster, I might get to some more stuff than what I did today. But yeah, you're welcome, Ed. But I've mostly done everything that's in here, and it's all solved.
Thank you very much.
Okay, yeah, study hard, guys. Study real hard. Let's do good on the midterm on Monday.
Have you ever been in Thailand?